My diorama is made of construction paper, tape, and a cotton ball. I use Sharpie to label and signify depth and water surface. The active continental margin is on the left. It begins with the continental shelf and a continental slope leading into the deep ocean trench. The deep ocean trench is formed at a convergent plate boundary due to the oceanic lithosphere being subducted beneath the edge of a continent. Next to that is the mid-ocean ridge. Mid-ocean ridges form from the upwelling of the mantle, which creates new oceanic crust. Due to this, they are elevated in comparison to the deep ocean basin. I've shown in the middle of my ridge a rift valley, which is a down-faulted structure along the axis of this particular ridge segment. Rift valleys can be extremely deep and wide. Next to that is the abyssal plain, which has 2 seamounts and 2 volcanic islands upon it. Both seamounts and volcanic islands are due to oceanic volcano activity. However, seamounts have yet to break the water surface. One of my islands is not active and would be considered an island, but the other is a volcanic island that is still active. The island that is not volcanically active will eventually turn into a guyute or a submerged seamount due to erosion and sinking. Going into the passive continental margin begins with a gradual incline called the continental rise. The continental rise can extend for hundreds of kilometers. It's created by a thick accumulation of sediment that has moved down the continental slope and it inclines into the continental slope, which is relatively steep and marks the boundary between continental and oceanic crust. In this passive margin, you'll see a submarine canyon in the slope, which are thought to have formed from turbidity currents or downslope movement of dense sediment-filled water. The slope eventually leads into the continental shelf. Overall, the passive continental margin is geologically inactive and located away from plate boundaries.